This video is on series. So a series is the sum of the terms of a sequence. Sometimes it is possible to see this expressed using sigma notation, which is what I'm just going to explain here. This doesn't come up often, but it can come up, so you need to understand what all the parts of it is. So this is the basic sigma notation. This top number here where the 5 is called the upper limit. So that is the top term we're going up to. So if we're looking at 5 terms in a sequence, the sum of the first 5 terms, 5 goes on the top. The bottom is n equals 1. N is the variable in the term. Sometimes that is there, sometimes it is not. If it's not and it just has a number, it means the same thing. And the number is the lower limit, so where are we starting? So in this sigma notation, we're going from term 1 to term 5, or from 1 to 5. Then the 3n minus 2 is a general term, so that is the equation we are looking at. So it means for all the n values from 1 to 5, we're going to sub them into there, and then we're going to add up all the answers. In an arithmetic series, depending on the information given, there are 2 formulas that you may need to use. These are both in the IB formula booklet. The first one is the sum equals n over 2 of u1 plus u to the power of n. So if we're looking to add up the first 10 terms, our n would be 10, and we would need the first term and the 10th term to work it out. If we don't know the term number of what we're trying to find, so we don't know what the 10th term is, we can use this equation instead, which is n over 2 brackets 2 times u1 plus n minus 1 multiplied by the common difference d. So depending on the information will depend on which equation that you use. Let's do a few examples. So the first one, an arithmetic sequence has first term 5 and common difference -2. Find the sum of the first 10 terms. So here we have that u1 is 5, and we know that d equals -2, and the first 10 terms, so n would equal 10. With that information, it would make sense to use the second formula because we've got all those parts of the information. So we're wanting to work out what is S10, and our n is 10, so we'll have 10 over 2, bracket 2 times u1, so it'll be 2 times 5, plus, open bracket again, n minus 1, so 10 minus 1 multiplied by our common difference, which is -2. Just put that straight into your calculator and we will get an answer of -40. So that is sum of the first 10 terms of this sequence. Example 2. An arithmetic sequence has u1 equals 10 and u30 equals 1000. Find the sum of all terms. So this one we have u1 equals 10. We know that u30 is 1000, and that means our n value is also 30 because we want to find the sum of all the terms. So we're going up to 30. So with this then, it means we'll use that first formula. Let me just quickly write it out here. So Sn equals n over 2 of u1 plus un. And if we sub in everything we have, so we're finding S30 equals n, which is 30 over 2, multiplied by 10 plus 1000, which gives us an answer of 15,150. So once again, both are very easy to use in the equations. It's just looking at what information you have to work out which is the best formula. Example 3, we're just going to have a look at this, just so you can see it with sigma notation. We'll do it by hand, but then we will also do it on the calculator. So we want to evaluate the sigma notation. So we've got a variable r that's going from 3 to 10 of the equation 5r plus 2. So we're going to sub in all the values from 3 to 10 and add them up. So this would equal, we're going to put in first 5, and we're starting at 3, so it'll be 5 times 3 plus 2. And then we're going to add the next one, so 5 times 4 plus 2, plus 5 times 5 plus 2. And I just didn't have quite enough space there, so we'll just put the 10 at the bottom. So we started with our n being 3, as per in the question, and going all the way up to n equals 10, as per the upper limit. And then when you work that out, you will get an answer of 276. Okay, now I'm going to go to the calculator and show you how you can put this into the calculator instead if it was a calculator exam. I want to go to a calculator page. Just go into this button that's next to the 9 here and click on that. You'll get up this things of all different functions and things that you can use. Now, if you look in the middle of the second line, we have our sigma notation function. So if we select that and press enter, Now we can just put in the question exactly as we have been given it. So we'll have r equals 3 on the bottom. Our upper limit was 10. And then we have 5r plus 2 as our equation. Press enter and we get the answer of 276 that we just found. Example 4, the sum of the first n terms of the sequence 3, 7, 11, 15 is 465. Find n. So let's just write down what we know. So we know that u1 equals 3. That the sum is 465, so Sn equals 465. And from this information, we can also work out that the difference equals 4. That's all the information we have right now. We don't know what n is. So we need to think about which sum formula is going to work, which would be this one. Because we don't know what un is for this many terms, we've only got the sum. We need to use that second formula, the longer one, this one here, to be able to solve the problem. Now we can just sub in all our information and we'll have 465 equals, we're trying to find n, so that just stays as it is, 2 times 3 plus n minus 1, we're trying to find n, so that will stay as n, multiplied by 4, our difference. Then we can just use our calculator to solve that. Once again, personally, I would just go straight into the graphing, find the intersection. As we're finding an n, how many terms, there would only be one solution, so you could also possibly use nsolve in this situation. And whichever method you use on your calculator to solve it, you will find out that n equals 15. Okay, we're going to look at geometric series now. A finite geometric series is where we know exactly how many terms we're going up to, 1 to 10 terms, just like we did with the arithmetic. Once again, 2 formulas for this. So Sn equals u1 multiplied by Rn minus 1, all divided by r minus 1, or u1 brackets 1 minus Rn, all divided by 1 minus r. So in this one, it doesn't matter which formula you use. Generally, the first formula we use for when r is greater than 1, the second one for when r is less than 1, but ultimately it doesn't actually matter. You can use either version, either way of this formula for all of it. So first example, a geometric sequence has u1 equals 16 and r equals negative 0.5. Find the sum of the first 8 terms. So we're given u1 and r, so we can put that into our sum formula. S8, so now as our r is less than 1, I'm going to use the second formula. So it'll be 16, open bracket, 1 minus negative 0.5 to the power of 8, because we've got 8 terms we're looking at, all divided by 1 minus negative 0.5. Put that into your calculator and we will get an answer of 10.625. Now in the IB, we always have to round to 3 significant figures, so always have an unrounded answer first, then round to 3 significant figures, which is 10.6. Example 2, we've got a sigma notation, just to have a look at that. And we're going from terms 2 to 8, and we've got 2 times 4 to the power of r. So our sum is going to equal, and then we're just going to put all our values in. So 2 times 4 to the power of 2, plus 2 times 4 to the power of 3. And we're going to carry all the way up to 2 times 4 to the power of 8. And when we calculate that, we will get an answer of 174,752. And once again, we could go to our calculator too, if we have that available in the exam, and put it in the sigma notation there to get the answer. And that is the end of this video.